Okay, in this lesson, what we're going to do is we're going to find the scores that mark the extreme something percent of a normal distribution. So in this case, let's say we're going to find the scores that mark the extreme 5% of this normal distribution. Now keep in mind, the normal distribution has two tails. It's got a positive tail and it's got a negative tail. So when we say we're going to find the extreme 5% of this distribution, we're going to have to divide that 5% up into 2.5% up at the top and 2.5% down at the bottom. Because the normal distribution is symmetrical, whatever the z-score is up at the top end on the positive side, it'll have the same value at the negative side. It'll just be at the negative value, but the same number. Our formula is similar to when we were only looking for one score. We're going to find two x values, so the positive x value and the negative x value is what we're looking for. And to find them, we take the mean plus or minus, so we'll get above the mean and below the mean, the z-score times the standard deviation. The mean for this example, which is IQ scores, IQ test scores with a population mean of 100 and a population standard deviation of 15. The mean is 100, the standard deviation of 15. The question is, what's the z value? And if I look in Appendix A, I'm looking for an area beyond z that's closest to 2.5% or 0.025, and what I find is a value of 1.96. So I know my z values now are 1.96 on the positive side, and on the negative side we have a z value of negative 1.96. Now all I have to do is do the math and I'll find out what my x values are. So 1.96 times 15 is 29.4. I plug that in. And notice, because I have the plus or minus sign, I'm going to have two values here. So on the positive side, the x value is going to be 129.4, which I plug in here. And to get the negative value, I subtract 29.4 from 100, and that gives me a score of 70.6. So to wrap words around it, I would say the scores that mark the extreme 5% of this normal distribution are 70.6 and 129.4 on an IQ test.